Now let's see the method of intervals to solve the inequalities, which is a very important and compact method to solve the given inequalities, which are involving not just quadratic expressions but any algebraic or rational functions in general. So here are the steps. Let's go through the steps one by one. First, we rewrite the given inequality in terms of some function in x. So it could be either f of x greater than 0 or f of x less than 0. Now we also need to factorize the f of x in terms of the individual factors. So that is what is shown here in general. That is x minus some number a1 whole raised to some index k1 multiplied by x minus a2 whole raised to k2 and so on, up to the last factor x minus an whole raised to kn. Now it's very important to note here that the term x must be positive here to use the method of intervals. That is, if there is any term which is negative in x, then we should change the sign and bring it in a way such that x is always positive. Now further we mark all these roots, that is the values a1, a2, a3 up to an. We mark all these values on a number line. Now next we put the plus sign to the rightmost interval, that is whichever is the value which comes on the rightmost side, the biggest value. The right side of that value we mark with plus sign, and then we scan towards the left, and as we cross each value we put the corresponding signs, that is plus or minus, based on a condition. That is, while crossing a particular value, if the power of that corresponding factor is odd, then we change the sign, but if the power is even, then we retain the previous sign. This will be clear when we actually solve the sums. And then lastly, once we mark all the plus minus signs, we collect all the required intervals based on whichever inequality we have been asked. So that is, if we have been asked the inequality of say greater than 0, then we collect all the intervals where we have marked the plus sign. If it is less than 0, then we collect all the intervals with minus signs. Let's move ahead. This is the method of intervals. Now let's see the questions based on this method of intervals. Say we have a expression, that is x square minus x minus 2 greater than 0. So we have to solve this inequality. It means we have to find out which are the allowed values of x which satisfy this particular inequality. Now here we see that we can definitely factorize this particular expression, which is x plus 1 into x minus 2, because that was the requirement of method of intervals. Now here we see that we have got the two factors. This particular expression can be considered as f of x. So now if we consider the first factor, the value which makes that factor 0 is nothing but minus 1, because x plus 1 can be visualized as x minus of minus 1. Similarly here, the value of x which makes that factor 0 is nothing but 2. So now we got two values, minus 1 and 2. So we mark those values on the number line. Since minus 1 is less than 2, it will come obviously on the left side of it. Alright. Now on the rightmost side, we always put plus sign, and then we start marking the signs leftward. Now as we cross the value of 2, we have to check which is the factor. The corresponding factor of 2 is nothing but x minus 2. Now for this particular factor, the power is 1, which is an odd number. So therefore, as per the rule, if it is an odd number, then we change the sign and now write the minus sign. Now once again, as we cross the next value, which is minus 1, we look at its corresponding factor and we see that its index is again 1, which is once again an odd number. So therefore, we once again change the sign and make it as plus. Alright, now the inequality is asking us about the expression to be positive. that is greater than 0. So therefore we collect all the intervals which have plus sign mark with them, which is the answer. So therefore x must belong to these two intervals. So writing both of them together, the first interval is nothing but from minus infinity to minus 1. It's an open interval because equality is not included. Union the another interval from 2 to infinity. So that's the solution set of the given inequality. Let's move ahead and see additional sum. Now here we observe that in this particular inequality we are already given the factors, but in the last factor we see that the coefficient of x is negative. So as required by the method of intervals, we must first make it positive. So therefore let's multiply both the sides by minus 1. So we will get x minus 1 into x minus 2. The third we will change the sign, and since we are multiplying inequality by a negative number, the inequality will reverse. Now it will become less than 0. So here once again the first factor will become 0 when x is 1, second factor becomes 0 when x is 2, the third factor will become 0 when x is 1 by 2. Therefore arranging these three values in sequence, we have first value as 1 by 2, we have 1, then we have 2, and we observe that the powers of all the factors are odd. So therefore marking with plus on the rightmost side, we alternately change the signs throughout, and since we want the expression to be negative, therefore we need to consider the intervals from 1 to 2 and minus infinity to half. So therefore the final answer is x must belong to minus infinity to half or 1 to 2. Let's go to the next question. Now here there is a very simple looking inequality, but we have to be very careful in solving this. Here we are most likely tempted to multiply both sides by x, but since we don't know about the sign of x, whether it is positive or negative, which would impact the inequality as greater than or less than, so therefore we cannot multiply both sides by x. But the correct way is to bring the 3 on left hand side, because 0 is a very important factor or the quantity that we must bring in solving the inequalities. So now let's cross multiply and merge into a single term. Now once again we see that now we have two factors, two linear factors in the numerator and denominator, but coefficient of x in the numerator is minus 3, which is negative. So to make it positive, we multiply both sides by minus 1, and because of this the inequality will change to greater than. Now here once again for the first factor we see the value of x to make it 0 is 2 by 3, and here the value of x to make it 0 is 0 itself, because it is just x here. So therefore now marking on the number line we have 0 and 2 by 3, and both of the factors have power as 1. So therefore the signs will be plus minus plus from right to left, and since we want positive, we mark off these required intervals. So therefore finally the answer is x must belong to the interval either minus infinity to 0, so in other words x must be negative, any negative value, or if it is positive then it must belong to the interval from 2 by 3 up to infinity without any doubt. That's the final answer. Alright, now let's go to next question, in which we have a slightly complicated rational functions given. So once again the strategy is same, that is we bring in all the terms on one side and have 0 on one of the sides. So therefore we have to say x minus 2 upon x plus 2 minus 2x minus 3 upon 4x minus 1 is greater than 0. Now we'll have to cross multiply here, of course, so that gives us x minus 2 into 4x minus 1 minus 2x minus 3 into x plus 2 whole divided by x plus 2 into 4x minus 1 greater than 0. Now on simplifying the numerator, we'll have to multiply both the brackets, then collect all the like terms. We finally get x square minus 5x plus 4 in the numerator divided by x plus 2 into 4x minus 1 greater than 0. Now we can see that the numerator can be factorized into two factors, which are x minus 1 and x minus 4 divided by x plus 2 into 4x minus 1 greater than 0. Now here we got the required function in the required format, that is all the factors are visible, the powers of all the factors are odd. Okay. So now to mark off with the values, that is first factor x minus 1, so the value of x is 1, then for x minus 4 it is 4, for x plus 2 it is minus 2, and for 4x minus 1 it will be 1 by 4. So therefore to mark it on a number line, the smallest value is minus 2, so therefore let's write it as minus 2 here. Then we have 1 by 4, then we have 1, and finally we have 4 as the largest value. So writing plus and then minus, plus, minus and plus. Since we want the greater than 0 inequality, we collect all the positive marked intervals. So therefore finally the answer is x must belong to, the leftmost interval is minus infinity to minus 2, or from 1 by 4 to 1, or 4 onwards to infinity. So that's the answer of this particular inequality. Now let's move ahead and see this particular question, that is we have to solve the inequality of x greater than root of 1 minus x. Now here once again we feel that we should square both sides so that we can get a quadratic equation and then we can factorize. But what happens is when you square, you are essentially covering more values, more possible values of x also, simply because whether it's positive or negative, the square will always be positive. So therefore squaring these kinds of relations will give what is called as extraneous roots, that is the extra roots which are not the actual roots of the given inequality. So we have to be first thoughtful of the restrictions on x, that is, see, if we see the right hand side, it's a square root, so that means the answer of that must be greater than 0. So therefore if x is greater than this particular square root, then automatically we have the first restriction that x itself must be positive. So this is one of the restrictions that we have. On the other hand, the maximum value of the maximum value of x also needs to be determined, because since we have this particular expression inside the square root, that expression must be non-negative. So that is 1 greater than or equal to x or x less than or equal to 1. So we get another restriction on x. So that way we try to fix the restrictions on x so that it helps us to finally write down the answer. Alright, now let us square the inequalities keeping in mind the two restrictions that we have. So now we can square the inequality and say that it is x square greater than 1 minus x. So bringing everything on one side, we have x square plus x minus 1 greater than 0. Now here we see that it's not that easy to factorize because we don't get integral roots or easy factors. So therefore let us use the direct formula. That is, if we consider the quadratic equation of x square plus x minus 1 equal to 0, then we will get the two roots as, here we have minus b which is minus 1 plus or minus b square is 1 minus 4ac, that is 4 into minus 1 whole upon 2a, which is 2. So therefore x is nothing but minus 1 plus or minus, we get root 5 upon 2. So just to write it in further detail, one of the roots is minus 1 plus root 5 upon 2 and another root is minus 1 minus root 5 whole upon 2. Now we have to keep an eye on the original restrictions that we had, that x must be greater than 0 but it has to be less than or equal to 1. Now if we see that, then this particular root, second root, automatically becomes invalid because it's a negative number. Now if we consider the other root, that is minus 1 plus root 5 upon 2, we know that the root 5 will be definitely bigger than 1, but it will be somewhere lying between 2 to 3. So therefore root 5 minus 1 whole upon 2 will be definitely less than 1, and since it's a positive number and less than 1, this qualifies the requirement on the restriction of x. So therefore the final answer is x must belong to the interval of root 5 minus 1 whole upon 2 to 1. Now since here we consider this particular interval because if we factorize into two parts, let's call the two roots as alpha and beta. So therefore our inequality becomes x minus alpha into x minus beta greater than 0. So therefore here we have alpha, here we have beta, that is plus minus plus, and since we want that to be plus, here of course the minus 1 plus root 5 upon 2 will be equal to beta because I have shown it as a bigger root, and the other one should be alpha now. So it is this beta, but we cannot cross the value of 1, so therefore this is the only permissible value of x. And since alpha is less than 0, although this interval is marked as plus, we cannot use it because of the restriction of x, that it must be positive. So therefore the final answer is this, that is the interval from minus 1 plus root 5 upon 2 to 1.